Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about collection hierarchy. So without wasting any time, let's get started. Alright, so in previous video I talked about what is collection framework, what problem it solves, and what is the need of collection framework in first place. So let's recall it once again. What is collection framework? So collection framework is a collection of standard data structure and algorithms that we can use to make our life easy. Alright, now we are good to go to do deep dive into all the interfaces and classes available in collection framework. So for your kind information, there are in total 9 interfaces in collection framework, and else remaining are concrete classes, means collection classes. Now the first question that we should ask ourselves is where all these interfaces and classes resides. So all these interfaces and classes resides in package called java.util. So once we import java.util, we will have access to all the interfaces and classes available in collection framework. Okay, moving on. So here you can see the diagram of collection hierarchy. So these are all the interfaces and classes available in collection framework. Although there are many interfaces and classes available in collection framework, these are some of the most commonly used interfaces and collection available in collection framework. So guys, in this diagram you will see two objects. One is green and one is blue. So all these green color objects here represents interfaces. This means iterable, collection, list, queue, set, deck, sorted set, map, sorted set are all interfaces. And all blue color objects are collection classes. Okay, this means array list, linked list, array deck, priority queue, hash set, linked hash set, and tree set, all of these are collection classes. This means these classes are capable of holding group of objects. Okay, I hope this is clear to you. So the first thing we should know about is what is interface. So the basic job of interface is to define methods that must be implemented by collection class. So here for example, iterable is an interface. So this interface must be implemented by all the collection classes like array list, linked list, array deck, and so on and so forth. If this interface had not been implemented by any of the collection class, then we would not be able to iterate through all the elements of the collection, because the iterable interface is responsible for all the features that are needed for iterating the elements of the collection, right? So let's begin with the first interface, that is iterable interface. So iterable interface defines two most used methods, and these are, first one is iterator and second one is for each. Okay, so whichever collection class implements iterable interface must implement the implementation of iterator method and for each method. And what is the job of iterator function? So whenever we call iterator function on any of the collection class, it returns iterator and that implements iterable interface. And using that iterable, we can iterate through all the elements contained in the collection. Okay, now the second method is for each. So when we call for each method on any collection that implements iterable interface, we can pass action to it, and this action is performed on all the elements contained in the collection unless all the elements have been processed. And it is a responsibility of all the collection class to implement iterable interface if they want itself to make iterable. Okay, now let's move on to the next interface, that is a collection interface. So as you can see in this entire diagram, the collection interface is the root interface of all the interfaces. Okay, here you can see that list interface also extends collection, queue is also extending collection, set is also extending collection, and collection is extending iterable interface. So what is the role of collection interface here? So basically collection interface provides all the basic functionality that are needed for all the collection class. For example, adding elements to the collection, clearing the collection, to check if the object contains in this collection or not, to check if the collection is empty or not, to get the size of collection, to convert the collection into array, or iterator. Okay, so collection class extends iterator from iterable interface, and then all the collection class implements iterable interface. So this is all about collection interface. Now let's move on to the next interface, that is a list interface. As you can see here, the list interface extends iterable and collection. So list interface contains all the methods that are available in iterable and collection, and additionally it defines few more functions or methods that are specific to list type of collection. So here you can see there are two types of list collection. One is array list and one is linked list. Okay. So array list is an implementation of array and linked list is an implementation of linked list. Okay, and the beauty of list collection is that it is an ordered collection. This means order is maintained. And one more advantage of using list collection is, so we have a precise control over the list of the elements where to put the new element. Okay, this means we can specifically define that on first position we have to insert the element, or we have to insert element at position 5th. So these are the functions that are additionally added by list interface. These are add. So this function used to add specific element to specific position. Remove method is used to remove elements from specific position, and similarly index of method is used to find the index of the specific object. So you can see that all the position specific methods are present in list interface. In addition to iterator method, list interface also define one more method, that is list interface. And the beauty of list interface is that whichever collection implements this interface must provide the implementation of list interface. And when we call list iterator, it gives us iterator, and that iterator is going to be bidirectional iterator. This means we can either go forward or we can go backward. But in case of normal iterator, we can only go forward only. Okay. So whenever we have requirement to store a group of objects in a collection in a form of list, we prefer to use array list and linked list, and wherein we can easily get and set item at a specific position. So this is all about list interface. Now let's move on to the next interface, that is queue interface. Okay, and queue interface also extends collection interface and iterable interface. So this means queue has all the methods that are available in iterable and collection, and in addition to that, queue also defines some new methods that are specific to queue. Okay, so first of all, what is queue? So queue is a collection that holds element prior to processing. Okay, so to understand the queue, the best example is printer queue. So what happens when we try to print 5 documents all together? Our printer take only one input at a time. So what it does, it stores all the documents in a queue, and it pick up one document at a time and process it. So this is what the queue is used for. Okay, so few of the methods that are defined in queue interface are add, remove element, offer, poll, and pick. The difference between these two functions are, this function throws exceptions while these functions do not throw exception. It simply returns special value, that is null. So for example, if the queue is empty and if we call remove on it, it simply throws exception. But in case of these functions, poll, if the queue is empty and if we call poll function on it, it simply returns special value. Now the question is, which collection implement queue interface? So as you can see here, priority queues implement queue interface. So this means priority queue must implement all of these methods to call itself queue. But in Java, priority queues is implemented as a minimum heap and maximum heap. So what happens in minimum heap, the minimum elements remain on top of the heap, and in maximum heap, maximum element remains on the top of heap. Now the question over here is, what is the use of priority queues? So guys, whenever we are concerned about the priorities of the element, in that case we use priority queues. For example, in case of patients in hospital, there are patients that needs to be treated as early as possible, and there are patients that can be treated anytime. So in those cases, in those application, use cases, we can use priority queues to assign priorities to all the elements or all the patients. So this is all about priority queue. Now the next interface that extends queue is dequeue. So what happens in queue basically? Queue basically follows FIFO policy. So what happens? The elements that comes first will be removed first. So the deck interface extend this feature and provide more features on top of queue. And we also call it doubly ended queue. So let's see few of the functions that are defined in deck interface. These are offer first, offer last, poll first, poll last, peak first, and peak last. So unlike queue, we add element on the back of the queue, but in deck, we can add element in the front of the queue or in the end of the queue. We can also remove element from front of the queue or remove from the last of the queue or from the end of the queue. And we can also check element in the front of queue, and we can also check element that are present in the front of the queue and in the back of the queue using the peak first and peak last method. Now the cool thing about deck is we can use deck as a FIFO queue, means the element that comes first will be removed first in, first out. And we can also use deck as a LIFO queues. And what happens in LIFO? The elements that come last will be processed first. Okay. Let's say if we want to use stack in any of our projects, then we can use deck interface, meaning the collection that implements deck interface. And in that case, we can use both the queues. If you want to use LIFO queue, we can use LIFO queues. If you want to use FIFO queues, then we can use FIFO queues. So if we use deck, we have all the features that are available in queue and that are available in deck. And the collection class that implements deck interface is ArrayDeck. Okay. And the second collection that implements deck interface is linked list. So both the collection implements deck interface. The only difference between ArrayDeck and linked list is ArrayDeck is implementation based on arrays and linked list is an implementation based on linked list. So it's up to us, whatever is feasible as per the use case, we can use linked list or array list. Now, the second interface comes up is the set interface. Okay, and set interface also extends collection and iterable interface. So this means set has all the features that are available in iterable and collection interface along with some other features that are specific to set. And the two collection classes that inherit set is hashSet and linked hashSet. Okay, but what is set? A set is a collection of values, contains no duplicates. So this means whenever we have use case where we want to store all the values but we do not need duplication, then we can use set. And when we want duplicate elements, we can simply use the list. Okay, we have list, collection, array list and linked list. In that case, we can use linked list and array list. Okay, so although set does not have any specific method defined in this interface, the responsibility of the collection class is to maintain the unique and distinct elements. So here there are two collection class that implement set interface. These are hashSet and linked hashSet. So hashSet is basically an implementation of hashing, okay, where hash table is used to store all the values. Now the linked list is the implementation of hashing and linked list. And why linked list is used? Because to maintain the order amongst the element, and this maintains the insertion order. So the order in which elements are inserted will be removed in the same order. Now, what if we want to sort elements in set? Okay, because as we know that in hashSet and linked set, the elements are not sorted. It is sorted based on the insertion order. But we want to sort elements in ascending or descending order. In that case, this sorted set comes into picture. Okay, in sorted set, elements are sorted in natural ordering, or we can provide comparator to sort elements based on our requirement. Okay, so the collection class that implements sorted set is treeSet. So, and this interface also defines few methods that are implemented by treeSet collection. First one is comparator. So comparator method is used to get the comparator that is used to sort elements of the sorted set. Okay, the first method is used to get the element at the first position, and last method is used to get the last element of the sorted set. Now, talking about the treeSet. So here treeSet is a collection class that implements sorted set, and internally treeSet uses self-balancing binary trees, and that are red-black trees, to maintain the order of elements as per the natural ordering or by the comparator. So when we create treeSet object, we can pass comparator if we want to sort all the elements in the sorted set, and if we are not passing any comparator and we want to sort elements, then the object should implement the comparable interface. Okay, so that the treeSet uses that comparator to sort elements as per your requirement. Okay, so this is all about sorted set. So far this diagram is completed. So we have covered iterable, collection, list, queue, set, deck and sorted interfaces. And we have also talked about all the collection classes that implements these interfaces. Now the next interface of collection framework is map interface. And the map interface does not extend any interface. And map interface is the root interface of all the collections that implements map interface. So what is map? So map is generally a collection of key value pairs. Okay, so whenever we want to map any value with the key, in those cases we can use map. Okay, so map interface defines all these methods, like clear method is used to clear the collection, contains key used to check if the key is present in the collection or not, and treeSet gives the set view of all the key value pairs, get is used to get the value associated with this key, isEmpty is used to check if the collection is empty or not, Key set gives a set view of all the keys of the map. Put is used to put a value associated with the key, and remove is used to remove the value mapped with the key, and size is used to get the size of map. Okay. Now the concrete class or the collection class that implements map interface is hashmap. So hashmap is again an implementation of hashing, where hash table is used to store all the key value pairs. Now hashmap does not make any guarantee concerning the order of the elements. So to solve this problem, the sorted map comes into picture, and the collection class that implements sorted map is tree map. So similarly, tree map also implements self-balancing binary tree, and that is red black tree, to maintain the order amongst the element. And sorted map defines few functions or methods that are specific to tree map. For example, entry set, key set, first key to get the first key, and last key to get the last key. And similarly, the elements that are contained in this collection class must implement comparable interface so that it can sort the element based on the comparator. And if we do not provide comparator and our objects have not implemented comparable interface, then tree map simply sort elements based on the natural ordering. Okay. Now we have covered almost all the interfaces and collection classes in the collection framework. We have also covered iterable interface, comparable interface. Now the last class that is remaining in collection framework is collections class. So mind you, here there is a S. This means this is a plural form of collection. And before we have seen the collection. So the difference between collection and collections is collection is a interface and it is a singular form, whereas the collections is a class that is present in collection framework. Now the question over here is, what is the use of collections class? Okay. So first of all, this collection class is also present in java.util package. And what is the job of collections class? It is act as a utility class that takes other collection as argument and operate on the given collection. So for example, let's say you have a list of elements and you want to search a specific element in the list of elements. In those cases, you can simply use collections class, and using the binary search method of collections class, you can pass list into that function, and this is simply going to search element in the given list. Okay. Similarly, if you want to copy one list to another list, you can use copy method of the collections class by passing two lists into it. And similarly, reverse method is used to reverse all the elements in the collection. Now the next is reverse order. So the reverse order of the collections class return comparator that imposes a reverse of the natural ordering on the collection of the elements that implements comparable interface. Okay. So long story short, if you want a comparator that reverse the order of the elements, you can simply call collections.reverseOrder. It will give you comparator and pass this comparator to the constructor of the collection class. The next method is shuffle. So as the name suggests, this method simply shuffles all the elements contained in the collection. Now the last one is sort. Sort is used to sort elements in the collection based on the comparable interface implemented by the elements of the collection. Now the next method is max and min. Max is used to find the maximum element among all the elements, and min is used to find minimum element among all the elements. So guys, by now I hope you have very good understanding of all the interfaces and collection class present in collection framework. So let's move ahead and see some of the advantages of collection framework. So the very first advantage of a collection framework is it reduces programming efforts. So how it's going to reduce programming efforts? It's pretty simple. As all the standard data structure and algorithm is already present in collection framework, we are not required to write all the data structure and algorithm by ourselves. We can simply use the predefined data structure and algorithm and we are good to go. Now the second advantage of a collection framework is increases performance. How it's going to increase the performance of the program? So for example, we are required to write a search or sorting. So what do? We have two options, either to write searching and sorting by ourselves, or we can directly use the searching and sorting that is available in collection framework. And if we write searching or sorting by ourselves, it may not be so performant, right? It may not be so efficient. But if we use already provided searching and sorting feature in collection framework, then we can assure that all these algorithms and data structure is efficient and performant. So the next advantage of collection framework is provide interoperability. Now this is really an interesting point. What does it mean by interoperability? So let me give you an example. So let's say in one project you have used ArrayList to store a group of objects. Okay. Now some other day you are not satisfied with the ArrayList implementation and you want to switch the ArrayList from linked list. So in that case, you can simply replace the ArrayList implementation with the linked list implementation without breaking the code. And why is it happening? Because both the collection class implement the same interfaces like list, collection or iterable. Okay. So this is why we can interchange the collection without breaking the code. And the second advantage is, let's say we have objects that are stored in ArrayList. So basically we have ArrayList and we want to convert that object into linked list. So how we do it? We have to simply create new object of linked list, passing the ArrayList in the constructor of linked list, and boom, we get the ArrayList. So this is how all the collection classes are interoperable. So we can use ArrayList in place of linked list and we can use linked list in place of ArrayList. Okay. So next advantage of collection framework is it reduces the efforts required to learn APIs. Now again, this is a really interesting point. We do not have to require to learn APIs of all collection classes. Why? The reason is simple. Because the add method of one collection class is same as add method of other collection class. For example, in case of linked list, the add method is used to add elements to linked list. In case of queues, add method is used to add elements to queue. In case of sorted set, add method is used to add elements to sorted set. Okay. So basically same APIs is used across the collection class, so we do not have to required to learn all the APIs. We just have to learn one API and we can use that API in all the collection classes. Now the last advantage of collection framework that is very much important is that it fosters software reuse. So what does it mean by software reuse? So it simply means collection class provides the standard interfaces and collection classes and algorithm so that we can reuse the same collections, same interfaces and same algorithm all over the places. We do not have to write everything by ourselves, but it also gives us flexibility that we can anytime want to change the implementation of any of the collection classes or algorithms. We can give our implementation as a custom implementation and we can use the collection and the algorithm as per our requirement. Okay. So guys, I hope you understood each and every advantage of collection framework so far. Now from upcoming videos, we will take one collection at a time and do a deep dive into that collection. So for example, in case of ArrayList, we are going to pick ArrayList and then we will see how ArrayList works internally, what are the operations we can perform on ArrayList and what are the time complexity of all the operations. So to do a deep dive into all the collection classes, stay tuned. Okay guys, so by now I hope you understood each and everything that is pertaining to interfaces and collection classes. So guys, I have to say this, if you have learned something valuable from this video, then hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming videos. So this is all from my side. Thanks for watching. See you in the next one.